Hello there, Algebra 2 students. How you guys doing today? We're back at it one more time. Today we're going to talk about lesson 16, which is conditional probability, which is slightly different than the probability we've talked about before. But as with many things in math, I do believe that it's a little bit difficult to kind of see what's happening, but once that thing clicks as to what the little trick is that you have to look for and do, it's very straightforward. So it might take you a second to have that one piece click, but I promise you once it clicks in, you're going to think these are pretty easy. It's just a couple things you have to look for in the question that's going to tell you to do something slightly different with the table, and then you're good to go. You will need a calculator today, so if you don't have one, go ahead and hit pause and go find one. We will be going back to it just to calculate those probabilities. Okay, so today we're talking about conditional probability. So conditional probability is a measure of probability of an event given that another event occurred. Here's what I mean by that. Let's say I come out of my classroom, if we were in school, and I see a backpack. And I think, okay, I wonder whose backpack this is. I could take the probability that probability adds one person's backpack out of the entire school, which I don't know how many people are in the school, but a lot. Okay, so if I thought about it, I found it in the hallway. It could be anybody in the entire school's backpack. Okay. However, what if I knew that somebody said, "Oh, I saw somebody come out of your class and put it down there." Okay. Well, now I know the person has to be in one of my classes, right? So what we would be thinking about is the probability of that whose backpack that is, given that they were one of my students. So when we say given that some other event has occurred, it means there's something else that we know that's going to reduce the total from everybody to a smaller subset of items. Okay, so in this case, it'd be students. So the probability would be much higher that I picked the student if I knew they were from my class, because one out of that number is going to be a larger number than one out of the entire school. Does that make sense? I hope so. Okay, so the notation, there's a particular notation that we use for this type of conditional probability, and when you see it, you have to know that's what it means. Okay, so here's the notation. P, capital P for probability, with parentheses, A, and then a vertical line, and then B. And what that means is that is the notation for the probability of A given that B has occurred. The probability of A given that B has occurred. Okay? And the phrase given that is going to be the key. When you see the phrase given that in the problem, this is a big red flag that we are talking about conditional probability. Look at that. It's a red flag. This is going to be a big red flag that we're talking about conditional probability. Let's look at it in practice. So here's one. All right, so the table shows the approximate distribution of students in geometry and algebra 2 by grade level. All right, so we look at the table real quick. We see a column for geometry, a column by algebra 2, and then we have rows each for 9th grade, 10th grade, 11th grade. Okay, so before I look at any of the questions, A, B, C, or D, do you remember what I always do when I find a table like this? I calculate my totals. All right, so let's add straight across to find out how many total 9th graders do we have. All right, 26 plus 0, that's 26. How many total 10th graders do we have? 68 plus 24, that's 92 10th graders. How many total 11th graders do we have? 33 plus 94, 127. All right, so now I'm going to calculate my totals for by the subject. All right, so how many total geometry students do we have? That would be 26 plus 68 plus 33, and that's 127. If you don't trust me, hit pause, grab your calculator. It's very possible I made a mistake. I might do that on purpose. You never know. Just kidding. All right, so here we go. Algebra 2, how many total kids do we have? 0 plus 24 plus 94, that's 118. Okay, now one of the reasons I do this is I want to know how many total people do I have in this. And this is a way to kind of check that I did this right. Because if I add the horizontally across the columns or vertically down the rows, I should get the same number. Okay, so let me start by adding 127 plus 118. That's 245. Okay, but now I'm going to take 26 plus 92 plus 127. I'm going to add straight down, and guess what I should get? 245. It should be the exact same number. Does that make sense? Okay, so once we did this, now we know what's happening. We know that there were a total of 245 students that were in this school or in these two grades. And we also have the breakdown by class, geometry and algebra, and the total breakdowns by grade, 9th grade, 10th grade, 11th grade. That's going to be very helpful going forward. Okay? All right, so let's look at A. Find the probability that a student is in 9th grade given that he or she is a geometry student. Okay, so now we're not talking about everybody. We're only talking about geometry students. All right, so here's a little shortcut. When you say the probability of 9th grade given that, that's what this line is, geometry student, in your mind, all you have to do is to change that into a fraction, and this is the probability we're going to find. The probability that we have a 9th grade student given that they are a geometry student. All that's going to happen is our denominator is going to change from everybody to what we know. In this case, we're not talking about everybody. We're talking only about geometry students. So we are focusing in on just this column of our table. How many total geometry students do we have? 127. Do you see how helpful it was that we did all that work ahead of time? All right, so how many 9th graders do we have? Now remember, we're only looking at this gray box. So how many how many 9th graders do we have? 26. So what's our probability? It's going to be 26 over 127. Okay, I could leave this, remember, as a fraction or as a decimal or as a percent. For number 1, I'm going to choose to leave it as a fraction. And we're done. 26 over 127, boom and boom. Are we good? Okay. All right, so on B, find the probability that a student is in 9th grade and is in geometry. Okay, so let's look at this question again. Do we see the given that? Do we see the vertical line here in the probability statement? And the answer is no to both of those counts. All right, so what does this mean? This means we're talking about everybody. So we're finding the probability that the student is 9th grade and in geometry out of the total. Okay, so how many people are in 9th grade and in geometry? 26. This is going to be 26 out of the total, which in this case was 245. So our probability here would be 26 out of 245. All right, they did this right next to each other so you could really see the difference between a conditional probability problem like A and a probability problem like we have done before, which is B. Okay, so if they don't say anything, you take it out of the total. But if they tell you you're looking at a smaller subset, then that's going to change the denominator of your probability. And that's it. That's basically conditional probability. We have a couple more examples to show you. All right, look at C. Find the probability that a student is in Algebra 2 given that, red flag, he or she is in 11th grade. All right, given that he or she is in 11th grade. And again, we see the vertical line. All right, given that they are in 11th grade. So what does that mean? We're going to take the number of Algebra 2 students and we're going to put it over the total number of people that are in 11th grade. Well, how many people are in 11th grade? All right, so I'm going to focus on, look at that green box, I'm going to focus on that bottom row of 11th grade, and my total there is 127. So 127 people are in 11th grade. That's just a coincidence that it happened to be the same number as in part A and B, or part A. All right, that's not always going to happen. Okay, but how many Algebra 2 students are there in 11th grade? That would be 94. All right, so we're looking at just this row. They ask us about Algebra 2, which is right here. So we're talking about 94 over 127. And again, I'll leave it just like that. Done and done. All right, part D. Find the probability that a student is in Algebra 2 and in 11th grade. All right, so notice if it says and, are we changing our denominator? No, we're talking about everybody. So if it's and, it will stay in the numerator. If it says given that, it will change the denominator. Okay, so we're talking about 94 over 245 because our total is out of everybody. Does that make sense? All right, number 2. Number 2 is great. Look what they did here. Sometimes you get lucky and they do something like this. In number 2, they gave you the total. All right, so you didn't have to do any extra work here on this table. They gave you the total. They gave you the total, which means what does this number here represent? All right, this number is the total of everybody. Okay, so each of these are the totals for the columns or the rows, and that number down the bottom right is everybody. All right, so this table shows immigration to the United States from 3 countries in 3 different years. Complete the chart and answer the question. So how many total people immigrated to the United States from these 3 countries in these 3 years? 65,846. Okay? All right, now let's look at A. Find the probability that a person is from Cuba given that the person immigrated in the year 1990. So we want the probability that someone is from Cuba given that they're immigrated in 1990. So we're not looking at everybody. We're looking only at those that immigrated in 1990. All right, so we're going to look just at this column, not at everybody. So our denominator is going to be 16,997. Now, how many of those people came from Cuba? 10,645. Set it up. And now, since these are really, really big numbers, whenever my numbers get really big, I tend not to leave them as fractions. I tend to go to the decimal. So grab your calculator. 10,645 divided by 16,997. Beep, boop, 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 beep, boop, boop, boop. It's about 0.6263, or you could say about 62.6% of the people came from Cuba in 1990. Okay? Are we good? Does that make sense? All right, let me erase this stuff. Let's do B. All right, so in B, it says find the probability that a person is from Spain and immigrated in the year 2000. All right, here's this keyword and. What does that mean? It means it stays in the numerator. Okay, so we're finding the probability that they were immigrated from Spain and in the year 2000, and this is going to be out of everybody. So our bottom will be 65,846. All right, so now we got to find the intersection of Spain, which is here. So we're going to look at this third row, and 2000, which is here, third column, which means we're going to look right here. So this number should be 1,264 divided by 65,846. I know I'm saying it a lot, but I wanted to sink in your brain. If it does not say given that, okay, it means that you're taking it out of everybody. So the bottom is our total, which is 65,846. Grab your calculator. Beep, boop, 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 beep, boop, boop, boop. 0.0192, or a little close to 2%, 1.9%. Okay. How are we doing? You want to pause it and try C on your own? We'll do it anyway. All right, here we go. Find the probability that a person immigrated in 1995, given that the person was from Ghana. All right, so right off the bat, we're excited because we see given that, so we know we're talking about conditional probability. We were so kind to even put it in bold for you. That means we're going to change the denominator. Okay, so we want the probability that they immigrated in 95 given that they were from Ghana. So Ghana is our denominator. It means that we are going to focus on that row from Ghana. Let me erase all of these from our last problem. Let's see. Here we go. All right, so now we're going to be talking about Ghana. So it means we're going to be focusing on this row here. So here's my question. What's the total that we're going to take this out of? What's our denominator of this probability going to be? Yeah, 11,962. This is the total people from Ghana. This is going to be our denominator. All right, so what are we looking for? We're looking for the probability that they immigrated in 95. So let's go to 95. That's right here, which means we're talking about this number right there. So it's 3,152 divided by 11,962. And that's it. 3,152 divided by 11,962. Grab your calculator. Beep, boop, 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 beep, boop, boop, boop. Equals 0.2635. And I think I rounded that, but that's okay. You're good. Anything close to that, you're going to be all right. And again, you know, most of the time this is going to be multiple choice. If you say, I only have 3 decimal places, you have 4, is that a problem? No. This question does not say, but always look to see if it does. Sometimes they want you to leave it as a decimal. Sometimes they want you to round it to a certain place. Sometimes they say leave it as a fraction. Sometimes they say convert it to a percent. You just have to look at the problem. And if they don't say, then you choose. And I always think plugging your calculator is pretty easy. Okay? All right, here we go. 2 down. We only have 2 more examples to go. Yeah, but Mr. Weber, they all have like 3 or 4 parts. Oh, well, you love it anyway. All right, here we go. Number 3, reporter asked 150 voters if they plan to vote in favor of a new library and a new arena. All right, the table shows the results. So you can see some people said yes to both. Some people said yes to the library, no to the arena, and vice versa. And then we have people that said no to everything. Okay, so total 150. So that should be our total. Remember what we're going to do first? We're going to go ahead and find our total. So why don't you go ahead and hit pause and do this on your own, and then hit play and see if you're right. Let's start by saying how many people said yes to the arena. All right, so 21 plus 30 would be a total of 51. 57 plus 42 is 99. All right, now let's think about the library. Let's add straight down. So 21 plus 57 is 78. And 30 plus 42 is 72. All right, so now we're going to add 78 and 72. That's going to give us 150. We'll add 51 and 99. That should also give us 150. Okay? All right, A. Find the probability that a voter plans to vote no to both the library and the new arena. All right, so do they say given that? No. So what's our denominator going to be? It's going to be the total voters, which is 150. Okay? So we want the probability that we say no to both over our total. Well, where's the probability that they say no to both? Let's find it in our chart. That means no and no means we're looking at 42 people. So this should be 42 over 150. And again, I'm going to stay in decimal world. So grab your calculator. Beep, boop, 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 beep, boop, boop, boop. 0.28. Done and done. Okay, now look at B. Find the probability that a voter plans to vote no to the new library, given that the voter plans to vote no to the new arena. All right, so now we have a givens that. All right, that means we're going to change our denominator. All right, so given that the voter votes no to the new arena, which means now we are focusing on this, no to new arena. So what's our denominator going to be? 99. All right, we want the probability that we say no to the library, given that we say no to the new arena. So given that changes our denominator. Now, how many people said no to the library in this row? That would be right here, 42. So now we're talking about 42 over 99, and that is 0.4242, and this repeats on. Okay. Again, you can see an example of how we're showing you one that is conditional probability and one that's not. So you can hopefully see the difference in the problem. You're just looking for that phrase given that. If you see that phrase given that, it changes the denominator. Okay, it changes the denominator. If you don't see given that, it means you're talking about everybody. All right, so C, find the probability that a voter plans to vote no to the new library and yes to the new arena. Do they say given that? Are we going to do anything? Who is this out of? This is out of everybody. Okay, so we want the probability that they say no to the library and yes to the arena, which means that we're taking this out of everyone. So our denominator should be 150. Okay, let's find our numerator. Okay, so we want to say, let me change my color here. I don't like that color. Let's do that one. Okay, so let's say we say no to the library. So here's our library. We're going to say no. So we're going to go down this column. We're going to say yes to the arena. So here's my arena. Here's my yes. I'm going to go across this row. Look for that intersection. Bam, 30. So this should be 30 over 150, which, grab your calculator, is 0.2. 0.20, same thing. So far, so good? Okay, D. Find the probability that a voter plans to vote no to the new library given that the voter plans to vote yes for the new arena. Okay, so what does that mean? That's going to change what we're looking at. So given that changes the denominator. So the denominator, given that the voter voted yes to the new arena, so we know they vote yes to the arena, which means we're looking at this row right here, which means our denominator should be 51. Okay, so now, what's the probability they said no to the library? This is 30 over 51, which raises our probability to 0.5882. Notice that anytime that we have a given that, anytime we have a conditional probability, that changes the denominator. It makes the denominator smaller, but what does that end up doing? It raises the probability. And again, if you think about it, that makes sense. If I had to pick a student at random out of the entire school, I would have a better chance of picking that student correctly if I knew they were out of my students, because there are less students that are just mine than in the entire school. So my probability goes up. Okay? All right, number 4. Last one, I promise. Maybe. We'll see. All right, number 4. The classes at the Dance Academy include ballet and tap. Here's the enrollment. In the table, what's the first thing we're going to do? Find our totals, hit pause and do it, and then we'll come back and get the answers. Let's find the totals for tap first. 38 plus 52 is 90. 86 plus 24 is 110. Let's find our totals for ballet, going straight down. 38 plus 86 is 124. 52 plus 24 is 76. Now let's find out how many total people are in these two classes. 124 plus 76 is 200. Just double check. 90 plus 110, also 200, so we're good. Does that make sense? Okay. Find the probability that a student is taking tap given that he or she is taking ballet. All right, so again, given that, did you see that big red flag? This means that our denominator is going to change to people that are taking ballet. That means yes to ballet, which means we're going to focus on just this column. So our denominator should be 124. How many people are taking tap? So yes to tap. 38. 38 over 124. Grab your calculator. Beep, boop, 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 beep, boop, boop, boop. 0.3065, and we're good. Does that make sense? All right, let's look at B. All right, I'll erase this stuff. So part B says, find the probability that a student is taking ballet given that he or she is taking tap. So taking tap is what we're going to focus on. So let's find tap. Yes. We're looking at this top row, which means our denominator should be 90. All right, we want the probability they say yes to ballet, given that they said yes to tap. So notice these probabilities are not the same. It's the same things that the same two things they're talking about. We're still talking about yes and ballet. We're still talking about yes to tap. But we changed the order given what we know, and that's going to change our probability. So now we're thinking about 38 over the total number of tap students, which is only 90. So it's 38 divided by 90. 38 divided by 90 is 0.4222. Does that make sense? All right, we got two more problems. C, find the probability that a student is taking tap. Look at that. Do we see a given that? No, we don't. What does that mean? That means we're taking it out of everybody. So we're going to find the probability that a student said yes to tap out of everybody. All right, so how many people said yes to tap total? That means they could say yes or no to ballet, which means the total is going to be 90. 90 people said yes to tap. This would be 90 over 200, which is 0.45. Does that make sense? You can see how helpful it is to have these totals out. So in the last section, when I told you to do this, I know many of you may have thought, like, I don't know why that's all this extra work, Mr. Weber. It's not really helping us out. Well, I was trying to set you up because here is where it really helps you out and it really will save you some time. All right, D, find the probability that a student is not taking ballet and is not taking tap. Okay, so they're not taking ballet. They're not taking tap. Do we know anything about the people? Do we know where they come from? No, we don't. There's no given that. That means it could be out of everybody or anybody. So we're going to look at 200 as our total denominator. We want the probability they say no to ballet and no to tap, okay, out of our total. Well, how many people said no to tap and no to ballet? That would be 24. So 24 out of 200. Grab your calculators. Beep, boop, 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 beep, boop, boop, boop. 0.12. And that is it. That is conditional probability. Remember, all conditional probability means is that we know something about where these items are coming, and so it changes our denominator rather than taking it out of all of the items to taking it out of only a subset of items. And in a table, that just means you're going to look at the denominator as being the total of a column or a row rather than the total of everything. And if you get that, then you understand conditional probability. And that's it. If you have any questions at all, please don't hesitate to reach out to your teachers. We are here for you. You guys have been working so hard all through this week, and I am so incredibly proud of each of you. Keep doing what you're doing. You're doing awesome. All right. Thank you, guys. Have a great one.